True bearing. True bearings are used to describe direction of an object from one to another. The direction is described by comparing it to true north. So all we're doing is like we're doing our directions, but like we know true north, or north as in north going up, is where we start, and then we go clockwise. So we start there, we go clockwise. If I say 100 degrees, I mean 100 degrees from true north. A couple of other things. It's always written in 3 digits plus decimals if necessary. So if you want to go 30 degrees, we'll write 30 degrees as 030. And then again, we're going from true north, so it'll be 30 degrees from here. So it looks something like this. So it'll be 30 degrees. That'll be a bearing of 030 degrees. So 30 degrees from the north. Suppose you're in town A, and you want to go to town B. So here's town A right here, and here's town B right there. If you start facing true north, so we're facing north, and you need to turn 48 degrees clockwise in order to face B, we say that the bearing of B from A is 048 degrees. So again, that's the bearing from B, bearing of B from A. So it means like you're at A, you want to go toward B, the bearing of B from A. So basically the from is where you're starting at. This is where we want to get to. This is the destination. So we want to get to B, and we're going from A. So we need to turn this degrees. Now, if you want to go backwards, like let's say you're at B and want to go toward A, we will say bearing of A from B, right? In that case, we start shooting off. We got to go all the way around to point to A. So you start here and you go all the way around. So if you're facing true north, you need to turn 228 degrees clockwise in order to face 180. The bearing of A to B is 228. Notice that the bearing from B to A is the bearing from A differed by 180. The way they figured that out is that these two are both true north. So that means they're parallel. They're going in the exact same direction. So and that means that this angle here and this angle there are same side supplementary. Since they're inside angles of two parallel lines. So if you want to figure out what this angle is, you just do 180 minus 48, which is 132. And then if you want to figure out what this outside angle is, you just do 360 minus that amount. Or you do 180 plus this guy. Same thing. Okay, let's do a couple of examples. Draw a diagram showing the bearing of B from A is 325. So again, we're starting at A. Here's my A. This is true north. And we want to go 325 degrees. So it's a normal grid, right? So this is 90. So we're starting like up here. This is 0. Then you go 90, 180, 270, and then 360 full round. So it'll be in here somewhere. And it'll be the direction from here to there. That'll be 325. Where this guy is B. So you start at A right here in the origin, and you got to go 100, and you got to go 325 degrees to find B. So something like that would be our diagram. Find the bearing of Q from P. So here's B, here's Q. We want to find the bearing. So remember, bearing's always starting at true north. So we always start right here, and we go clockwise. So we're going down there. Well, if this is 90, like I talked about before, right? Half of 180, then this is 90 minus 30, so this is the bearing of 060. Remember, bearing should always be three figures, 3 decimals. Decimals is not the right word. 3 digits. There you go. This one, now remember, bearing's always from north, so bearing's always north and going clockwise. So we want this guy. So this will be 360, a full circle, minus 52. So that's going to be 308. So that'll be our bearing here, 308. Because remember, we always go from true north. Find the bearing of A to B, the bearing of A from B, if the bearing from B from A is that. So, it sounds a little complicated, but what's going on here is this. Here's A, with their true north. And then, here's B somewhere. Actually, we gotta drop B in a second. So find the bearing of A from B if the bearing from B of B from A is 206. So let's draw 206. So if I was doing a straight line, right, this would be 180. Let's draw a little grid here. 270. So 206 will be around here. Let's say this is 206. And this is B. So now I want to go backwards and find the bearing from B to A. So I'll draw a little grid here. Now all this is 206. So it might look a little confusing. Really, all we really care about are the north poles. So like if I was drawing it again, here's my pole B, here's my pole A, right? They're connected right here, and if we figured out this was, they told us this was 206. So we want to figure out what this guy is right there. So how do we do it? Well, the way I would feel the most comfortable doing this, if I'm honest with you, would be like, okay, I can figure out what this is. That is 360 minus 206, which gets me 154. This is 154. Remember, these are parallel, which means if I want to figure out what this angle is, which is the thing I'm trying to find, that these two are same side supplementary. So I'll do 180 to find that. I'll do 180 minus 154, which will give me 26 degrees. So that's one way to do it. Another way to do it is, if you remember from what we did earlier, you can go just subtract this from 180 to get that. But there we go, 26 degrees. Next one. When Samantha goes jogging, she finishes 2 kilometers south and 3 kilometers west of her starting point. Find Samantha's bearing from her starting point. So let's say she starts here. Now she goes 2 kilometers south, so put a little grid here, never eat shredded wheat or whatever. North, east, southwest. So we're going 2 kilometers south, and then 3 kilometers west. Now from that spot, we're going 3 kilometers west. And find the bearing from a starting point. So we're trying to find, let's draw a line that connects it all. Now remember, we're trying to find our bearing. So we're not trying to find this angle. That angle is super important though. We're trying to find the bearing. So we're trying to go from true north. So what we're really trying to find is all of this. That's what we're trying to find. Right, all that. Now how do I do that? Well, half of this is 180. So I got to do 180 plus whatever that angle is. How do I find the angle? Well, it's a triangle. Right, we have a triangle right there. This is 2 kilometers. This is 3. It's a right triangle, piece of specific because we went straight north and straight west. And we're trying to find out what that guy is. So let's list out our sides. This is opposite. This is adjacent. So it is tan TOA. So tan of theta equals opposite or adjacent. So remember, to get rid of the tan, we're going to do tan inverse of both sides. And we get theta equals, I got to do tan inverse of 3/2. So let's turn that on, make sure I'm in degrees. Yes, I am. So tan inverse of 3 divided by 2. And we get about 56.3. Right? Again, that's this theta. That's this guy. To find the bearing, I'm going to add it to 180. And I'm going to get 236.3 degrees. Is my bearing. It's Samantha's bearing from where she started. So that's the way it works. My bearing always means it always comes starting from the north. Let's do another example. When Kenneth cycles in the hills, he finishes 30 kilometers west and 24 kilometers south from where he started. Find the Kenneth distance from the starting point. This is like a very similar problem, but I put this one in here. Okay, so 7. So he starts at here. He goes 30 kilometers west and 24 kilometers south. Not drawn a scale. This should be smaller. Something like that. Like that. Right. Find Kenneth's distance from the start point. So we just do this. Right, now to find his distance, the thing we're going to do is, we don't have any angles, so we're going to do a squared, b squared, c squared. So we're going to go 24 squared. Remember, hypotenuse is the right side, so we're looking for that. So So 24 squared plus 30 squared equals x squared. Again, hypotenuse is the only thing that matters, and that's your c. So I'm just going to put that into a calculator because I know what that is. So we're going to do 24 squared plus 30 squared. And we're going to take the square root of that. Come on. There we go. We get 38. So I get 1476 equals x squared. Square root. X is approximately 38.4. So that's the distance from start to approximately 38.4 kilometers. In which direction is the starting point from where Kenneth is now? So, in which direction is the starting point from Kenneth now? So we want to know the bearing. So again, remember the way we do this, we go, it's always a true north. So here's our north, so where we start, we're trying to find this angle all the way to here. So we can know which direction he is from our starting point. So we're trying to find all that. To do that, let's draw a little straight line here. And let's draw a little line right there. Now, I'm a little bit of a pickle, right? So I got to find out what all of this is. And actually, that's wrong. That's be 270. I got to figure out what all of this to here is. That's the right angle, right? If I did all this, I'd be going a straight line. And I want from here to here. So that's my bearing. Now, I don't have this angle here, so how do I find it? A couple ways. I could figure out, use arctan again to find out what this angle is, and then subtract that from 90 to get this angle. Or I could just draw it differently. Right, we have this. Instead of drawing it like this, it's the same thing if I draw it this way. Right? If I go, I go down 24, and then west 30. It's to me the exact same. To me, this angle will be exactly the same as this one. So either way you want to do it. I guess in that case, I don't even need to do this. I can just make a rectangle here. Right, just do this. This would also be 24, and this would also be 30. And I just need to find out what that guy is. So theta, if you look at my sides, this guy right there is opposite, and this is adjacent. So we're going to do tan of theta equals 30 over 24. Let's take the tan inverse of both sides. Again, I'm using a calculator. 30 divided by 24. And we get 51.3. But again, just like last time, that's this angle here. If I want the bearing, I'm going to go all the way from the north. I'm going to add 180 to that. And I'm going to get 231.3. And that's the direction we have to go from the starting point to get to the direction. So again, 231.3 is like, okay, starting from true north, like you have a compass. That's the whole idea. You have a compass, right? So for that, I'm going to go 231 degrees this way, and I go there. Next one. A courier departs from her depot A and drives on a 136 course for 2.4 kilometers to intersection B. Okay, let me figure that out. So we have A here. It's always helpful to draw the true north. And going 136 degrees. Now if I do this and that, 136 degrees will be in between these two. 90, 180. So we're going like around there. 136. Right? To intersection B. I guess you don't need this. All we need is that. So there we go, 136 from there to intersection B. And this is 2.4 kilometers. He turns right, and at the intersection drives 226 degrees course for 3.1 kilometers to his destination C. So from here, he goes 226 degrees. So driving going like this way, right? Like that. And remember, this is 180 straight line. This would be 270 if he actually did this. This is 270 because it's 0, 90, 180, 270. We're going 226, we're going this way. To the point C. I'm deleting some of that because I just wanted to make it a little clearer to see the value. So we get that. So something like that is what my picture looks like. And this is 3.1. Like that. Find the distance from C to A. So I gotta find this distance here. Now my guess is that this is gonna be a 90 degree. This is trying to be a 90 degree triangle. Because that's the only thing we've learned so far is how to deal with that. We eventually learn how to do it with all type of triangles, but we haven't technically learned that. So how do I show it? But before I do that, I gotta show this is 90 degrees. So how do we do that? Let's figure out what this angle is. So this is 136. Remember, this angle here, these two are same side supplementary. So that means if you add them up, it should equal 180. So I'm gonna do 180 minus 136 equals 44. So this is 44 degrees. So that's 44 degrees. This is 226 degrees. So how do I figure out what this angle is right here? Well, it's a full circle, right? We have a full circle right here. So we're gonna do 360 minus 44 minus 226. Let's see if I put these together. I'm gonna get 4. I get 280, 270. Yeah, I get this right here is 270. 360 minus 270 is 90 degrees. So yes, this is the 90 degree angle. Again, that won't always be the case. So as of right now, we really only know how to solve 90 degree right triangles. So that is a right triangle. So if I want to find the distance from A to C, I'm just going to do A squared, B squared, C squared. So to find this distance right here, right, I'm just going to do A squared, which is 2.4, B squared 3.1, and we'll find out what C squared is. So 2.4 squared plus 3.1 squared is equal to x squared. So we're trying to find that. Remember, that's the hypotenuse opposite 90 degree angle. It's the only part that really matters because that's the one that's by itself. We use a calculator. I get 2.4 squared plus 3.1 squared. And I get 15.37. And then we're going to square root both sides. So we get 3.92 equals x. So again, approximately 3.92 is this. So there we go. The bearing of C from A. So again, of C from A. A is where you're starting at. So of C from A. So what that wants is this guy. It wants all of that, right? The bearing of C from A. So we're coming from A. So I want all of this. To do that, well, we know this angle right here is 36. We got to figure out what this angle is. So let me redraw that triangle. Right, we have this is a right angle. This is 2.4. This is 3.1. We just figured out this is 3.92. And we're trying to figure out what this angle is. Because if we figured out what this angle is, we could add that to the 136, which is this portion of it, to get the full bearing. So let's do. I like to use the ones they gave us, so I'm not going to use this one. I'm going to use this one, which is opposite, and this one, which is adjacent. So we're going to do tan again. Tan of theta equals opposite of adjacent. Yeah, I always think it's better to use the given values than the ones you found, because the ones you found is a little bit rounded. So we're going to do second tan of 3.1 divided by 2.4. And we get about 52.3. But remember, that's only this inside part. So let me delete this over real quick. That blue we found. Too much. Right. Now we know this is 52.3. So we can add the 136 plus the 52.3 to get the full bearing. So I'm going to get 188.3. And that's the full bearing of C from A. So there we go. Last one, I believe. Yes. Yacht A and B depart from the same point. Yacht A sails, fun problem, I guess. Yacht A sails 11 kilometers on the bearing of 034, and Yacht B sails 14 kilometers on the bearing of 124. Find distance and bearing of Yacht B from Yacht A. So they start in the same spot. So like this. You start there, right? I think sometimes it helps to draw the little XY graph. Okay. Yacht A is in Yacht B. Yacht A sails 11 kilometers on the bearing of 034. So remember, here's 0. True north is 0. Here's about 0 degrees. 0 degrees. This is about 90 degrees, 180, 270, and then 360 will be back up here. So they go 034. So we're like going like this. We're close to the line. So this is the Yacht A. Say 11 kilometers. That's about 34 degrees. Yeah, Yacht B's sails at 40 kilometers at a bearing of 124. So 124, this is, again, we're still going from bearing, so 90, 180. So 124 would be around here somewhere. Yacht B. This is a 124 is again from the north. So 124 is all of that. So that's all 124. It's another 90-degree problem because that's all we know how to solve. Okay, sorry. This is 14 kilometers. And then they want you to find this is from Yacht B and A, and then find the bearing. So we want to find this guy. Alright, so we're looking for that. And then we also want to find the bearing from bearing B from Yacht A, and we'll talk about what that means in a second. But first thing, how do we solve this? Well, again, only thing we learned how to solve so far is 90-degree angles, and you can see that here. This is 34, this is 124. So I was looking for this guy right there. That would be 124 degrees, which is the whole thing, the whole bearing from here to here, minus the 34-degree bearing right there. And you get 90 degrees. So this is a right angle, which makes this a hypotenuse. So we can solve it by figuring out what A squared plus B squared is. So remember, hypotenuse is the only thing that has to be by itself. That's the only thing that matters. That's x, and you have 11 and 14. I don't know how to solve that again, so we'll just do it in a calculator. So 11 squared plus 14 squared gets me 317. And then we take the square root of that. So second square root, our answer. And I get x equals 17.8, like that. So that's our x, 17.8, roughly. Okay. And now we want the bearing from A to B. So my drawing's not that helpful. Let me draw it again real quick. So we started here, and then we went this way to get to A. This was 34 degrees. And then somewhere down here is B. And what we're looking for is this bearing right there. That bearing. Now, a couple things to help us out. Like I said before, we know what this is, 34, so we know what this guy is. These two are parallel because they're both going true north. So all we have to do to figure out what this angle is 180 minus 34, which is 146. So that's that measurement. This guy right here is part of a triangle we just solved. Right, where this was 90 degrees. It's a bad right angle, but yes, it's supposed to be a right angle. Right, and we know this was 11, this was 14. So we'll figure out what this angle is. Right, because all it is a right triangle. Try to figure out what that is. And once again, it's opposite over adjacent, another tan. So tan of theta equals 14 over 11. So we're going to inverse tan that. We've only done this like 13 times so far. Second tan 14 divided by 11. And I get 50. I feel I get the same answer every single time too. 51.8 about. So this is 51.8. Now if we want to find, sorry, I wrote it right here, 51.8. Now if we want to find that true bearing, all we're going to do is, this is a full circle, 360 minus these two. So to find the bearing of B from A, remember, that's why we found that one, because it says of B from A, we're starting at A and going toward B. So what's that bearing? It's going to be 360 minus 146 minus 51.8. So let's do that on the calculator real quick. So 360 minus 146 minus 51.8. And we get 162.2. There we go. That's the lesson.